Okay. Hi, everyone. We are the Floc app subteam. We're creating a web app for plant operators to check the size of their flocks. This data will be used to determine if more or less coagulant should be used. Floc app is aiming to expedite the feedback process in the coagulation process. To do this, we're creating a web application that will count and size the flocks. Using this data, the coagulation teams will have more accurate information within a faster time frame that they can use to adjust their coagulant levels. Ultimately, this solution will save time and cost for the plants because it will cut the cost of turbidity meters, excessive coagulant, and additional labor. This web application will work offline as well to ensure that the plant operators can access the web application even if Wi-Fi is not available. In the past, the Floc app subteam has worked to write scripts that are capable of processing images taken by a microscopic camera. This is done using machine vision techniques. The scripts are capable of analyzing an image and detecting individual flocks before grouping the closely located flocks together and counting them as a single larger flocks. The images are passed through a black and white filter in order to easily detect the flocks within them. The image shown here shows on the top an image of the flocks taken, and then on the bottom, an image of them after they've gone through the machine learning techniques. Previous image analysis is also shown in the appendix. In addition, the team has built the skeleton of a graphical user interface, or GUI, displaying all of the necessary buttons for the user, which we'll be working on adding additional functionality to those buttons. In order to build the app, we need to use many different tools. First off, we are programming the app using Python, which is an interpreted high-level programming language that is known for its code readability and is integral to debugging. Thus, we use PyCharm as our integrated development environment as it works particularly well with Python. We are using GitHub to facilitate version control and ensure that we can all work to use the code together. OpenCV is a library of programming functions with real-time computer vision capabilities that are necessary for real-time image processing. And finally, we're using SQLite, a database management system, to store data gathered from the size and count scripts.
Okay, and as for our process, we started off by essentially setting up and installing the right software, and then also installing the right libraries such as OpenCV and PyQt. And then from there, we tried to familiarize ourselves with the code from previous years, which although were well documented, they were also the algorithms were very complex, so that took some time. And then after that, we started to write code. And then as for our method, essentially there were three parts. The first one involves the algorithm, which is a CV algorithm that is trained on photos from previous years. And then that will eventually detect flock size, and it counts the flocks as well. And then the second part, the camera, it's connected to our webcams for now. And then it also takes photos every 5 seconds. And then lastly, we created a database, and after the photo is taken, it's connected to the front end of the database. And then each time the algorithm is applied to the photo and analyzes the number of flocks and then sends them to the database. And then this is an example of the front end of the web application. So you press the red button, so it'll take a picture every 5 seconds, and then there's an option to export, and then that will export the size and count of the flocks into an Excel spreadsheet. Yeah, and this is an example of how it works.
All right, and like we talked about earlier, we have a backend using SQLite, and effectively it's just a database that stores the count and the size for each flock. and use a unique ID for each Floc image. And you can add, remove, or retrieve data for all the different Flocs. And it's all stored offline in one single database file. And the reason we chose SQLite is because it works offline and it works really well with Python and PyQt, which are our software. And you can also export it to CSV if you prefer. So when setting up the app, we have all these different dependencies with Python, PyQt, SQLite, OpenCV. And even for us who are like experienced developers, we've had tons of issues downloading it all and getting them all working together so we can run the app. So we definitely don't want to pass these like pains along to the plan operators. So we tried to combine all the different dependencies into one kind of container. And the way we're doing that is with Docker. And it kind of works like shipping containers, where they're all like, if you think about the containers, they're each one standardized size. So you can go on any different cargo ship and they all fit together. And that's kind of how Docker works, containerizing all these different dependencies and puts them all in one format that every computer understands how to work through. And previously we tried just doing like a freezer with CX freeze, which converted the app into like an executable, but that still depended on like the operating system of the computer, whereas Docker builds that in to the container. And Docker containers are just more flexible and should be able to work with pretty much any device. However, after talking with the Agua Clara founder, Monroe, we realized that we're still kind of long-term vision. We're still a couple years out from shipping the app to the plan operators, and we should probably focus more of our time on just improving the app. So our future tasks, our main one is to keep improving the flock detection algorithm. And we're going to try using gradients to help determine like the edge of the flock, figure out where it ends and where kind of white space begins. And we're going to try to store the date and time of the photos in the database so we can do more cool analysis with that. And that includes creating data plots. And primarily, we just need to do more testing as soon as we have access to the camera. And that's going to be key to improving the flock detection algorithm. And long term, we'd love to create some sort of algorithm that can use the flock size data to provide coagulant levels. So just convert the information we're getting into recommendations for how to manage the coagulant. Here's the appendix. And yeah, that's it. We're Floc app.